In this video, we are going to explore corrosion and in particular understand what causes rusting and how we can effectively prevent it from damaging important materials over time. Corrosion is a general term used to describe the slow breakdown or deterioration of metals as a result of chemical reactions with substances in their environment such as oxygen and water. One of the most common examples of corrosion is rusting, which specifically occurs when iron reacts with both oxygen and water from the surrounding air or moisture. This reaction produces a reddish-brown flaky substance known as hydrated iron oxide, more commonly called rust. On an atomic level, rusting is a redox reaction, which involves both oxidation and reduction processes occurring simultaneously. In this case, each iron atom in the metal structure loses 3 electrons, becoming an iron 3+ ion. At the same time, each molecule of oxygen, made up of 2 atoms, gains a total of 4 electrons, becoming 2 oxygen 2- ions. Because the iron is losing electrons, we say it is being oxidized, and because the oxygen is gaining electrons, it is being reduced. This makes rusting a classic example of a redox reaction since it involves both of these chemical processes happening in a single reaction. Now, for rusting to take place, 2 conditions must be met. Iron must be in contact with both water and oxygen from the air. This can be demonstrated through a simple experiment involving 3 test tubes, each containing an iron nail. In the first test tube, we place boiled water with a layer of oil on top to prevent oxygen from entering and dissolving into the water. The boiling removes any dissolved oxygen, and the oil acts as a seal to keep new oxygen out. In the second test tube, we keep the nail in dry air by using a drying agent, such as calcium chloride, which removes all water vapor from the air. This setup provides oxygen, but no water. Finally, in the third test tube, we place the nail in normal air, with water, meaning it has both oxygen and moisture. If we leave all 3 test tubes undisturbed for several days, we find that only the nail in the third test tube rusts, confirming that both oxygen and water must be present for rusting to occur. It is important to understand that corrosion only affects the outer surface of a metal, since only that part is directly exposed to environmental substances like air and moisture. When iron rusts, the rust layer that forms is loose and brittle and tends to flake off. This exposes the next layer of fresh metal to air and water, which then also begins to rust. This cycle continues layer by layer until eventually the entire structure of iron can completely disintegrate. In contrast, when metals like aluminium corrode, they behave differently. Instead of flaking off, the oxidized outer layer of aluminium forms a thin but very stable layer of aluminium oxide, which acts as a barrier, protecting the metal beneath from further corrosion. This means that aluminium objects generally do not corrode all the way through and are often more resistant to environmental damage than iron or steel. Now, let's talk about how to prevent rusting. There are generally 2 broad categories of methods that we can use to protect iron from rusting. These are known as barrier methods and sacrificial methods. The barrier methods work by creating a physical shield between the iron and the external environment so that oxygen and water cannot reach the surface of the metal. There are 3 main types of barrier protection. One of the simplest is painting the metal surface, which is useful for large structures like bridges or ships. Another is applying oil or grease, which is especially important for machinery or moving parts such as bicycle chains that need lubrication. The third method is electroplating, which involves using electrolysis to deposit a thin layer of another metal such as chromium or tin onto the surface of the iron. This not only gives a protective layer, but often improves appearance as well. On the other hand, the sacrificial method works differently. It involves attaching or coating the iron with a more reactive metal such as zinc or magnesium. Because these metals are more reactive than iron, they will corrode first when exposed to oxygen or moisture, and in doing so, they protect the iron from reacting. A classic example of this is galvanizing, which is a technique where iron is coated in a thin layer of zinc. This provides double protection. Firstly, the zinc layer acts as a barrier preventing contact with water and oxygen, but even if the zinc coating gets scratched or damaged and the iron underneath is exposed, the zinc will continue to offer protection by reacting first. Due to its higher reactivity, this makes galvanizing both a barrier method and a sacrificial method at the same time, providing very effective long-term protection against rusting. Anyway, that brings us to the end of this video. We hope you found this explanation helpful in understanding corrosion, rusting, and the different strategies used to prevent it. If you enjoyed this content, please consider giving us a like and subscribing to the channel for more helpful science videos, and we'll see you again soon.